In this episode of Exploring Data Science, we'll consider 9 different data mining tasks. So here are the 9 data mining tasks which we're going to consider. We have classification, regression, similarity matching, clustering, co-occurrence grouping, profiling, link prediction, data reduction, and causal modelling. First off, let's consider classification. Classification and class probability estimation attempt to predict for each individual or entity in a population which of a small set of classes this individual belongs to. Usually, the classes are mutually exclusive. An example classification question would be, among all the customers of a particular company, which are likely to respond to a given offer? In this example, the two classes could be called will respond and will not respond. For a classification task, a data mining procedure produces a model that, given a new individual, determines which class that individual belongs to. A closely related task is scoring or class probability estimation. A scoring model applied to an individual produces a score representing the probability that the individual belongs to each class. Regression, or value estimation, attempts to estimate or predict for each individual the numerical value of some variable for that individual. An example regression question would be, how much will a given customer use our service? The property, or variable, to be predicted here is service usage, and a model could be generated by looking at other similar individuals in the population and their historical usage. A regression procedure produces a model that, given an individual, estimates the value of the particular variable specific to that individual. Regression is related to classification, but the two are different. Informally, classification predicts whether something will happen, whereas regression predicts how much something will happen. Similarity matching attempts to identify similar individuals based on data known about them. Similarity matching can be used directly to find similar entities. Similarity matching is the basis for one of the most popular methods for making product recommendations, i.e. finding people who are similar to you in terms of the products they have liked or have purchased. Similarity measures underlie certain solutions to other data mining tasks, such as classification, regression, and clustering. Clustering attempts to group individuals in a population together by their similarity, but not driven by any specific purpose. An example clustering question would be, do our customers form natural groups or segments? Clustering is particularly useful in preliminary domain exploration to see which natural groups exist, because these groups in turn may suggest other data mining tasks or approaches. Co-occurrence grouping is also known as frequent item set mining, association rule discovery, and market basket analysis. It attempts to find associations between entities based on transactions involving them. An example co-occurrence question might be, what items are commonly purchased together? Co-occurrence of products in purchases is a common type of grouping known as market basket analysis. Some recommendation systems also perform a type of affinity grouping by finding, for example, pairs of books that are purchased frequently by the same people, or people who bought X also bought Y. Profiling is also known as behavior description, and it attempts to characterize the typical behavior of an individual, group, or population. An example profiling question might be, what is the typical mobile phone usage of this customer segment? Behavior can be described generally over an entire population, or down to the level of small groups or even individuals. Profiling is often used to establish behavioral norms for anomaly detection applications, such as fraud detection and monitoring for intrusions to computer systems. For example, if we know what kind of purchases a person typically makes on a credit card, we can determine whether a new charge on the card fits that profile or not. We can use the degree of mismatch as a suspicion score and issue an alarm if it's too high. Link prediction attempts to predict connections between data items, usually by suggesting that a link should exist. Link prediction is common in social networking systems. For example, since you and Bob share 10 friends, maybe you'd like to be Bob's friend. Link prediction can also estimate the strength of a link. For example, for recommending movies to customers, one can think of a graph between customers and the movies they've watched or rated. Within the graph, we search for links that do not exist between customers and movies, but that we predict should exist and should be strong. These links form the basis for recommendations. Data reduction attempts to take a large set of data and replace it with a smaller set of data that contains much of the important information in the larger set. The smaller dataset may be easier to deal with or to process. Causal modelling attempts to help us understand what events or actions actually influence others. Techniques for causal modelling include those involving a substantial investment in data, such as randomized controlled experiments, for example A/B tests, as well as sophisticated methods for drawing causal conclusions from observational data. Both experimental and observational methods for causal modelling generally can be viewed as counterfactual analysis, in that they attempt to understand what would be the difference between situations which cannot both happen.